Hey there, it's Workbench of Workbench Quagmire here with another day of Free Code Camp's Python certification in 100-ish days. And today we are going to look at numbers and mathematical operations. So let's just dive right in. How do you work with integers and floating point numbers? Integers and floats are the primary numeric data type in Python. With them, you can store numeric data and perform mathematical operations. Let's look at what integers and floats are, how to perform arithmetic calculations with them, and at several methods Python provides for working with both. Integers are whole numbers without decimal points, either positive or negative. So here we are with the variable named myInt1 that's assigned the integer 56, and myInt2 that's assigned the integer -4. And so here we print type myInt1. So that's type is going to return the class int thing here, and then Python's going to, or print, sorry, is going to print it. So again, I'll mention this again. These are nested functions, so which is very common. The next line, print myInt2, gives us the same thing. So it doesn't matter if it's positive or negative. Those are both ints. Here's how to perform addition operations with integers. So we got our ints. myInt1 is 56. myInt2 is 12. Sum of the ints equals myInt1 plus myInt2. Print integer addition, sum int. That gives us 68. So subtraction, as you might guess, minus sign. So diff ints myInt1, myInt2, print integer subtraction, and that gives us 44. Multiplication operations with integers. myInt1 is now 12, myInt2 is 4. Product of ints equals myInt star. So this is the, on the US keyboard, this is the character you get when you hit Shift 8. myInt2. So print integer multiplication, product ints, and that gives us 48. Here's how to perform division operations of integers. So myInt1 is 56, myInt2 is 12. Div ints equals myInt1 slash divided by myInt2, integer division, div ints. Remember this comma, just a reminder here, is what gives us our space between integer division and our div ints output. Floats are positive or negative numbers with the decimal points like 3.14 or minus 0.5 or 0.0. So my float 1 is minus 12.0. My float 2 equals 4.9. My int type float 1, float, print type my float 2, which is also a float. Again, sign doesn't change the type at all. Here's addition of floats. So my float 1, my float 2. We got 5.4 for my float 1, 12.0 for my float 2. Float addition equals my float 1 plus my float 2. Same as integer division or as integer addition. Ugh, stuff to spit out. Here's subtraction operations. My float 1 is 5.4, and my float 2 is 12.0. Again, just the minus sign here, and that gives us 6.6. Multiplication's exactly the same. We use the same operator. And that one gives us, is that 68, 64.8000001. And just so you know, you look at this, you go, well, it should be 64.8. But when you start calculating out a lot of decimal points, it turns out that your CPU's not as super accurate when you get long numbers like that. So um, that's why you might see that. In a lot of cases, it won't matter because you'll format it in such a way so it rounds to a 2 or 4 or 6 digits or whatever, and it wouldn't matter. Division operation with floats is exactly the same as integers. So my float 1, 5.4, my float 2, 12.0. Float division equals my float 2 divided by my float 1. And when we print the float division variable, it's 2.2222222. If you add an integer and a float, the result will automatically be converted to a float. So sum int and float equals my int, which is 56, plus my float, which is 5.4. So we're going to end up with print sum int and float. It'll give us 6.14. And then if we look at the type, it is float. It's one of those cases where I believe we discussed previous lessons that Python kind of manages some of this for us, right? So in some cases, like you cannot add integers and strings, but in this case, it will manage that to say, hey, if you have one float in your expression, then everything needs to be a float as far as numbers. So this is true for other basic basic arithmetic operations too, like subtraction, multiplication, division. If you mix integers and floats, Python will return a float as a result. You can also perform complex arithmetic calculations, such as getting the remainder of two numbers with a modulo operator, floor division, and exponentiation. That's a word, with both integers and floats. So the modulo operator, the percent sign, returns the remainder when the value on the left is divided by the value on the right. So in this case, we have my int 1 as 56, my int 2 is 12, my float 1 is 5.4, my float 2 is 12.0. Mod ints equals my int 1 modulo my int 2. So this would be as if we took this and divided by it, and then we give the remainder. And so the same thing goes with mod floats. My float 1 modulo my float, or my float 2 modulo my float 1. So they did it in the opposite direction there. And so print integer modulus mod ints, and that gives us 8. Print float modulus. So float modulus is 1.199999993. Floor division divides two numbers and returns the greatest integer less than or equal to the result. This is done with double forward slash operator. So we look at this here. My int is 56 again. My int 1. My int 2 is 12. My float 1 is 5.4 again. My float 2 is 12.0. Floor division ints. My int 1, which is 56, divided by 12 is going to give us 4, because that's the largest integer that it will return without having a remainder. Floor division floats, my float 2 divided by my float 1. And again, in this case, it gives us 2.0. So it gives us a round number because that's what it demands. Floor division demands a whole number, but it is still a float, so you get the 0.0. Exponentiation raises a number to the power of another and is done with the double asterisks. My int 1 is 56. My int 2 is 12. Float 1 and float 2 are the same. Exponent ints. My int to the power of my int 1 to the power of my int 2, and then exponent floats my float 1 to the power of my float 2. And down here, we get some very large numbers, especially here. Yeah. Python also has a built-in function for converting either numeric data or strings into integers or floats. So the float function returns a floating point number constructed from the given number. So if we take my int 1, which was 56, and we can assign my float 1 can be assigned to float int my int 56. So you can see here when you print it now, it has 0.0 on the end, and the type of my float 1 is a float. The int function returns an integer constructed from the given number. So in this case, it's a float with a 0.92563 at the end. And then my int will be int my float. In this case, it truncates the float and just returns 12. And you can see there it is a integer value. You can use the same built-in functions to convert a string into either a float or an integer. So in this case, because this has the quote marks, here this is actually a string. My string int is assigned to the string 54, not the integer 54. And my string float is assigned to the value of 7, the string value of 7.8, not the float value. And so convert int my string int, and convert float to my string float. You can see down here by the print statements, when you print them, you get 45, and then that variable has the type of int, and you get 7.8 with a type of float. Here's some other methods Python provides for working with integers and floats. Rounds a number to the specified number of decimal places. By default, the function rounds to the nearest integer and returns a whole number with no decimal places. So my int 1, 4.798, my int 2, 4.253, rounded int 1, round int 1 with no other argument. That's going to give us a 5. And then round int 2 with the argument 1 will give us 1 decimal point. So we get 4.3 for that one. Abs, which is the absolute value, gives us the absolute value of the number, the abs function. It does not, in fact, give you abs. I've checked. Number assigned to minus 15, the integer minus 15, and the absolute value equals number, the abs function with number as the argument. So when we print that abs value, you get 15. So power raises a number to the power of another or performs modular exponentiation. So result 1 equals power 2 to the 3. So it's equivalent to this 2 star 3. Print the result, you get 8. Result 2 power 2, 3, 5, which is what you get there is you get the same 2 to the 3rd power, but then it takes it modulo 5. And so in that case, it returns 3. So when you divide 8 by 5, the remainder is 3. Okay, time for our quiz questions. What does the double dash / operator do in Python? It divides two numbers and returns the greatest integer less than or equal to the result. That's true. It performs regular division and returns a float. That is not true. It represents a comment in Python. That is not true either. We learned that comments in Python are I can't remember what I was going to say there. It raises a number to the power of another. It does not. So it's number 1 there. Which statement correctly describes integers in Python? Integers can only store positive whole numbers. Integers are numbers with decimal points. Both of those are not true. Integers are whole numbers without decimal points, either positive or negative. That's true. Integers automatically convert to floats when performing division. That is not true. Which method returns the absolute value of a number? Abs, that's true. Round is rounding. Sum is not that, and max, no, it's abs. Let's check our answer, see if we're correct. We did it. We're halfway through. So, how do augmented assignments work? So, augmented assignments combine a binary operation with an assignment in one step. It takes a variable, applies an operation to it with another value, and stores the result back in the same variable. If you're familiar with languages like JavaScript, you've probably heard of the addition assign operator, plus equals, or subtraction assign operator minus equals, and those exist in Python too. The only difference is they're referred to as augmented assignments. So we used with strings, we found that you could use the plus equals to concatenate strings, right? So if you have my string one that has the value string assigned to it, and then you say my string one plus equals float, then you'll get string float all as one word. So the basic syntax of an augmented assignment looks like this: variable operator, so plus, minus, and value. So you're taking the variable value, doing the operation to it using the value provided on the right, which is a more efficient way of doing this. Variable equals variable plus value or minus value or whatever. So for example, here's an example. Too many examples in that sentence already. Using augmented assignment to add 5 to an existing variable. So my var equals 10, my var plus equals 5, and if we print that now, it's going to give us 15. And here's the same thing, but without the augmented assignment. My var equals 10, my var equals my var plus 5. It gives you the same thing. It's just less typing. All right, the subtraction assignment operator subtracts the right operand from the left variable and stores the difference in the left variable. So similar concept, different operator. Count equals 14, count minus equals 3. When we print that, it's going to be 11. The same goes for the multiplication operator. So you got the multiplication assignment operator, multiplies the left variable by the right operand and stores the product back in the left variable. So in this case, product is 65, product times equals 7, gives us 455. The division operator, the same thing, 100. 100 divided by equals 4 is 25. And floor division also applies. So total pages is 23. Total pages floor divided by equals 5, which is confusing, is 4. Modulus operand computes the remainder of the left variable divided by the right side and stores it back in the left variable. So in this case, bits equals 35, bits modulo equals 2. And so if you were to divide this by 2, you would get 12 or 1, and remaining is 15, 7, and then there would be a 1 left over, correct? And so now bits is just equal to 1. The exponentiation assignment operator, so it raises the left to the right. So 2 to the third is 8. You can use some augmented assignment variables with strings too, like we did previously in the string section. So hello, greet plus equals space, because remember, if you don't have that, it'll just run, literally put them one after another. So when you now print it, it's hello world. And multiplication assignment operator can be used with strings too. So it's just greet, hello. And then if you put greet times equals 3, it's going to put hello, 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 hello. And remember, it's not going to add a space. So, it's going to run those strings all together just the way they are stored in the variable. Other augmented assignments throw a type error when you use them with strings. So here we go with hello and space world as our two. With the minus equals space world, well, you can't subtract. What are you doing? There's no world to remove. I don't know what's going on there. So, of course, you're going to get a type error. Unsupported operand types for minus equals string and string. Same thing for the division operator. You can't divide hello by world. That doesn't tell you how to do anything, so it doesn't work. So if you're wondering if increment and decrement operators work in Python, they don't. That's because it deliberately avoids C-style increment and decrement shortcuts in order to keep the language clear and explicit. Maybe sometime we'll go over some of the kind of general rules, or maybe they'll go over the general kind of high level, like, hey, here's how you should write Python type items. Instead of x plus plus, you can simply write x plus equals 1. So, same effect, slightly different syntax. And then writing plus plus x in Python just applies the ulnary plus twice and does not increment anything. Or unary, not ulnary. Python just applies the unary plus twice and does not increment anything. So if you print plus my var, which was started with 5, it's just var. And if you print plus plus my var, then you still get 5. And plus 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 my var, you still get 5. But my var plus equals 1, you get 6. Right, time for our questions. What is the main advantage of using augmented assignment operators? They automatically convert data types. No, they present all possible syntax errors. They prevent all possible. It'd be kind of cool if they presented all possible syntax errors and said, "Don't do any of this." But they don't. They prevent all possible syntax errors. That's not true. They provide a concise way to update variables without repeating the variable name. That's true, and they make mathematical operations faster. Nowhere in there do they say it makes mathematical operations faster. What happens when you use increment and decrement error operators in Python? They work exactly like C, C++. No, they do not. They cause a syntax error and crash the program. Yes, they are interpreted as double ulnary operators with no actual increment decrement. That's sort of true, I think. I may not get this one right. They only work in Python 2. No, that's not true. I'm going to go with that. So, which augmented assignment operator raises a variable to the power and stores the results back in the variable? That is the power variable in some other languages. I think maybe JavaScript. That is not it in Python. This is what we're looking for in Python. This is the multiplication augmented assignment operator. And again, that doesn't really apply in Python. So here we go. Check our answers. Ooh, I got it right. All right. So there we go. Numbers and mathematical operations. That's tomorrow. We will cover, which is day 6. Today is day 5, I believe. I don't know if I said that at the beginning of the video or not. Okay, tomorrow, Boolean conditions. How do conditional statements and logical operators work? And what are truthy and falsy values, and how do Boolean operators and short circuiting work? So that will be tomorrow. Thanks for watching the video. Don't forget to like and subscribe. Leave a comment. Let me know, what do you like? What do you not like? Is there something you didn't understand? And I can address that, hopefully. See you then.